Hello everyone, welcome back to my channel Traceroute. So today we'll talk about Envoy Proxy. Yeah. If we were to rewind early 2000, the way computer systems were set up was quite different. Back then, we used proxies that were set up in a fixed way, and everything was managed from a central point. Most of the communication protocols, except for HTTP, were focused on the fourth layer of the networking model. Fast forward to today, we are living in a world dominated by cloud technology. What's evident is that things are much more dynamic now. The setup of our proxies changes a lot more frequently because now we are constantly adding new services. Moreover, it's not just one central system anymore. It has become a more decentralized, you can say, with various groups of proxies working independently. The shift has moved towards the seventh layer of the networking model. However, with the rise of microservices architecture, the number of services has increased significantly. This means what? This means we are now we need to basically add extra measures to make sure that our applications can withstand problems and we can keep a close eye on what they are doing, how they are doing. It's all about making sure that our applications are available and performing well in this new and more complex landscape. But with this dynamism comes chaos, a lot of chaos actually. Entered Envoy Proxy, the knight in shining armor for the microservices world. So what exactly is Envoy Proxy? Envoy Proxy, a modern high performance, you can say high performance edge and service proxy designed for cloud and microservices applications. It is originated at Lyft. Now it has become a CNCF project. Whether it's a Kubernetes or traditional VM-based applications, Envoy is designed to support all types of services. Envoy abstracts the complexities of the network from the application, simplifying the development and deployment process. With APIs for dynamic configuration, Envoy facilitates agile and responsive management of its settings. Envoy goes beyond the basics featuring like load balancing, goes beyond the basics. It offers features like load balancing, retries, circuit breakers, rate limiting, and whatnot more. Keeping up with the modern protocols, it does support HTTP2 and HTTP3. Envoy is equipped to collect and expose metrics and logs, provided valuable insights into the performance and behavior of your services. Envoy, it is designed to basically scale seamlessly, allowing applications to meet varying demands of efficiently and dynamically. You can say it has become the standard in modern cloud architecture. So basically, Envoy Proxy combines all these essential features, making it a cornerstone in today's cloud native landscape. Let's see how we can use Envoy Proxy. So we can deploy both. We can deploy Envoy Proxy as sidecar deployment as well as API gateway. So in sidecar deployment, what happens is it actually Envoy was originated as a service mesh sidecar proxy only, factoring out all the complexities of load balancing, routing, observability, security, and discovery services from applications. In this case, the Envoy proxy instance would have the same lifecycle as that of the parent application. So if you deploy it as an API gateway, it acts as it basically sits as a front proxy between the client request and the application. This will accept inbound traffic, do a TLS termination, authentication, collecting all the information that is required from the request and directing it to wherever it needs to go inside the service mesh. So let's understand how exactly the Envoy architecture looks like. So here you can see it has a downstream, which means anything which is coming from the client side, or say anything coming to Envoy is basically a downstream, and anything behind Behind Envoy is upstream, which can be like origin server or a web server. So yeah, the request processing path in Envoy has basically two main parts, you can say. One is a listener subsystem, another one is a cluster subsystem. So the listener subsystem handles downstream request processing. It is also responsible for managing the downstream request lifecycle and the responsive path to the client. The cluster subsystem, it is responsible for selecting and configuring the upstream connection to an endpoint. This is where the knowledge of upstream cluster and endpoint health load balancing exists over here. The two subsystems are bridged with the HTTP router filter, which forwards the request from the downstream to upstream. So basically, Envoy operates on a threading model that consists of a main thread, and a set of worker threads, often referred to as listener threads, basically. So when Envoy is initiated, it dynamically determines the number of worker threads based on the available cores in the system. While manual configuration of thread numbers is possible, the default behavior involves Envoy examining the system's CPU information. Basically, it just does the cat proc CPU info kind of a command and see what all the system CPU information it has, and launching an equivalent number of worker threads. Each of these worker threads assumes the crucial role of handling the connection initiated by the listener over here. This threading architecture allows Envoy to efficiently distribute the workload across multiple threads, enhancing its capacity to manage concurrent connections and optimize performance in line with the system's capabilities. So let's say we have a web server. Okay, we have a web server, and just like Envoy, our Envoy is listening on port number 443. Okay, so which is nothing but a TLS port. So that means if the Envoy has n number of worker threads, all of them will be listening onto this particular port, and port this 443. And based on kernel scheduling, what happens is that whenever a connection comes to the TCP port 443, it will go to one of these worker threads. So basically, all of them will be blocked onto this. All of them will be blocked onto the accept call, and then when the connection comes, one of them will get invoked. And for the entire duration of that particular connection, it will remain within that worker thread. This thread is completely responsible for the end-to-end connection of that connection. So any business logic like role-based access control, RBAC, authentication, rate limiting, be anything, everything will happen within the context of this worker thread. This worker thread is like done with a connection, it will generate. So once this worker thread is done with the connection, what happens? It will generate some access log with all the interstate parameters, and based on how access log is configured in your configuration, so it will send these logs to the tools or peer service according to whatever you have configured in this Envoy proxy configuration. You can say this is more of a detailed diagram of how Envoy processes the request. First, we will go through the network filter side, network filter level of Envoy working. So in order to dig deeper into like how Envoy processes incoming requests, let's take a closure loop, like how it's inner workings, like how it works. So yeah, it all begins with what we call listeners, right? As I mentioned, like we have two subsystems, listeners and clusters. So it all begins with the listeners. These listeners are essentially named network locations, identified by an IP address and port, or you can have a UDS, like Unix domain socket path as well for your listener network locations. They act as an entry point for anything coming from the downstream, meaning any connection requests directed towards the Envoy are received through these listeners. When received, they are intelligently scheduled to one of these worker threads that I have mentioned earlier, right? So now, inside of these worker threads, Envoy exposes a trio of filter categories. One is the listener filter, right? Then there is a network filter, and then there are HTTP filters. So these filters play a pivotal role in determining like what action needs to be taken for whatever the request or incoming packets, you can say, whatever the incoming packets we have, what all actions we need to take for these packets. So first of all, what happens is that first is the listener filter. So they sing into action immediately after a packet is received, typically focusing on the packet's header. So for instance, there is a TLS inspection listener filter, which scrutinizes the traffic to check if it's TLS encrypted or not. If so, then what it will do, it extracts the pertinent data from the TLS handshake. Next in line, what we have is the network filter. So these filters, so what happens is these filters basically primarily operate on the packet's payload by scrutinizing and parsing its content. So you will find various network filters in play, including the TCP proxy filter and other custom tailored to specific network related tasks. One particularly noteworthy network filter, you have to keep that in a note. So one particularly noteworthy network filter is the HTTP connection manager, or often referred to as HCM, right? So what it does is it has the unique capability of translating raw bytes into HTTP level messages, so that HTTP filters will act on it. So it has the capability of translating raw bytes into HTTP level messages. It comes in handy like whenever you need to process requests as a HTTP layer, as I mentioned. So here is the key point. So if your processing doesn't involve any HTTP specific task, you can focus on that, just the TCP related processing, and then seamlessly pass the packet along the upstream service. No need for HTTP level filtering, right? But yeah, so like Envoy is very much flexible filter system, right? So you can tailor your needs or its behavior according to your specific use case, ensuring that requests are handled with precision and efficiency. Next comes the HTTP level of processing, like HTTP filter chain processing. So when the request comes, when it comes to handling HTTP specific processing, right, in Envoy, we have the flexibility to apply a specific set of HTTP filters tailored for each domain, like determined by the SNI, right, SNI or host, right, seen in the connection. For instance, let's say we have, let's consider two domains, abc.com and let's say xyz.com. So we can configure distinct set of filters for requests directed to each of these domains. Let's say we have abc.com, which will follow this path, and we have xyz.com, which will follow this path. So for abc.com, we have a different custom HTTP filter chain, and then for xyz.com, we can have a custom filter chain and then the router, right? So here, like how the HTTP filter chain works. So as I mentioned, domain specific filter, right? So depending on the domain indicated by the SNI in the connection, Envoy applies the corresponding HTTP filter. These filters can be tailored basically to meet the requirements of each domain, allowing for precise customization. Then there comes the router filter. In each of these filter chains, we have a router in common. So what it does is, like in the HTTP filter, the last filter in line is the router filter. This filter serves as the decision maker once HTTP processing is completed. What it does is it determines the cluster to which the packet or HTTP request should be directed. It is responsible for routing tasks, such as deciding whether to redirect, forward, or rewrite, or find a direct response from the Envoy itself to the client, right? Then we have basically the cluster subsystem, right? As I mentioned in my previous slide, right? So so in cluster subsystem, what happens is like the clusters are critically the building block in Envoy architecture. They represent a group of similar upstream hosts where application services run to accept the incoming traffic. It can be like a set of web server or whatever you can say as your endpoint. So, so these individual hosts, like within a cluster, are basically referred to as endpoints. Envoy it plays role of traffic conductor, load balancing, incoming requests among these endpoints, ensuring efficient distribution of load. That is what the Envoy does over here. Yeah. So yeah, so this is the main it has become a common nowadays, but like Envoy, so you can say it is a key feature of Envoy actually. So this is a dynamic configuration, which is like a very important feature that sets Envoy apart, providing powerful flexibility in how it's configured, right? We have like statically configured proxies, but like here it is like the Envoy can be dynamically configured. So Envoy primarily serves as a data path element, right, where all the customer traffic flows through it. So rather than hard coding all the information about the cluster or endpoint, what Envoy does, Envoy embraces dynamically configurability via the control plane, right? So here how this dynamic configuration works. So we have a discovery service known as an XDS server. So instead of static configuration, Envoy leverages a gRPC or REST-based discovery service to dynamically fetch information about listeners, routes, clusters, and endpoints. So this discovery service acts as a control plane for the Envoy and storing all the configuration details and pushing updates to Envoy via gRPC calls. So configuration over gRPC, right? So so Envoy establishes a connection with the XDS server. So these are Envoys, and it establishes a connection with the this XDS server over gRPC calls. So to retrieve the crucial information about its configuration. So this will include configuration, listener configuration, route definitions, or cluster details, and much more. The beauty of dynamic configuration lies in its ability to make changes without restarting the Envoy process. So you don't need to, so whenever the such update happens for any of these things, right? So you don't have to basically restart your Envoy. That's the beauty actually. So it will make all the changes without restarting the Envoy process. When configurations are updated on the Access server, Envoy can seamlessly adapt to the changes without any downtime. Yeah. So thank you all for joining this tutorial on Envoy Proxy. If you have further questions or topics you would like to explore, or feel free to leave them in the comments. And please don't forget to hit the subscribe button